We'll start a new section on tree models. And unlike the previously considered models that would draw a line to split the region into two areas, the tree model split region into multiple areas. And instead of using lines, they use a vertical or horizontal line. So in regression would have a line that can move in any direction. And in classification, we also would have a line that would split objects of one class from objects of another class. So it was always the single line that would does the predictive rule for us. In the case of tree models, we actually have multiple lines, but all of those lines are either vertical or horizontal, so they're parallel to the axis. Let's consider a very simple one-dimensional case. And let's consider the problem of regression. So let's say I have this data set. It's just x and y, and the observation are like this. Okay, so building a single line here wouldn't make any sense. So instead, if you just look at this plot, right? So let's say, this is 1, this is 2, and this is 3. Okay. So if you just look at this plot of this data, a very simple regression rule would just should come to the top of your head, and the rule should be like this. If x is between 1 and 0, then y will equal, let's say this is 1, let's say this is 0.5, and this is 0.3. Okay, then y equals to 1. If x is between 2 and 1, then y equals to 0.3. And if x is between 3 and 2, then we set y to 0.5. And if x is between, actually here we don't have a left end, so we only have x is greater than 3, then we say y equals to 1 again. That's pretty much it. That's the tree model. You just look at the data and you try to see how to split your input space into the regions, and the regions in one-dimensional case are just intervals. In two-dimensional cases, that's going to be boxes, and boxes can be closed, so all four sides are defined. An open box, meaning one of the sides basically goes to infinity. And we can apply the same rule to classification or regression. It doesn't matter. So if you have classification example actually come pretty soon. The reason that we call those models tree models is because instead of defining those regions in this way, like I did here, by explicitly writing down the boundaries for the x variables, we define them using a tree. So if you look at this one, so the tree is going to be like this. So the first node of the tree is whether x is less than 1 and greater than 0. So if yes, we basically say y equals 1. So the left branch always will be yes, right branch always will be no. If no, then we check if x is less than 2. And if yes, then we say y equal to 0.3. And if no, then we check if x is less than 3. And if x is less than 3, then we say yes, y equal to 0.5. And if it's greater than 3, then we say y equals to 1. So it's the same information as here. We just written down in the form of a tree, and it's just more convenient way to represent those regions as a decision tree. That's why we call it a tree model. Let's look at an example. So we will analyze baseball data, and you saw similar data, so we try to relate technical characteristics of a baseball player to the salary. And the data set is called hitters. So it has multiple characteristics of the player: number of bats, number of hits, runs, and how many years player has been playing, and then the Y column is the salary of this player, which we don't show here just because we don't have enough space on the screen. So there's also salary column here. And salary is our Y variable, and we're going to use two of those variables as our X variables. Okay, so we're going to use years of experience and number of hits as our predictors. And what you see here is just the scatter plot of the data. And since it's we have two predictors, so we plotted the points on the plane, and the Y variable is indicated by the color of each of those dots. So the blue dots are the lowest salaries, and the red dots are high salaries. So you see a red dot here, you see a red dot here, another red dot here. So those people with high salaries, and anything in between the blue and the red is in between high and low salary. Now let's just look at this plot and try to do the same thing as we did for my artificially designed data set on the first slide. You can see visually pattern here. You can see that in this region here, you have a lot of the blue dots. So a lot of the people with very small number of years are not getting high salaries. So it looks like years is a very important predictor, and we can just easily separate low salaries from high salaries by drawing a line somewhere here. So let's actually do that, right? So there's a line somewhere here. It looks like everything on the left of this line, the salary is going to be lower compared to the right of this line. So, and let's look at the right hand side of the divided area. And we also see some type of pattern here. We see that most of the red dots going to be on the here in the upper quadrant here, and the bluer dots or darts which correspond to low zero is going to be in the lower quadrant. So maybe we want to separate again something like this. Okay, so we have three regions. We have region 1, region 2, and region 3. And again, here I just graphically shown it to you, but usually in the computer the model will be represented by a tree, and the tree will look like this. So you have two variable years and hits, and first you check whether years is less than 5, and if that's the case, then we have to come up with some way to do the regression now. So you see there are points here of different values. And now how do we regress? So if basically if you have a point somewhere here, this is my new point. Let's do it in red color, like this. So that's you get the new point, which you need to define a salary for this person. And the way that regression tree works is it will take all the salaries in this region, will average them out, and the average will be used to regress. So if your number of years, actually let's write explicitly years so we don't confuse it with Y variable, less than 5, then you say my Y hat will be equal to Y1 bar, where Y1 bar is just the average value across all of the points in this region 1. So let's write it explicitly. Y1 bar is 1 over number of points in region 1, and you have I goes from 1 to number of points in region 1, and you average y i's in this region. So each of the y's here belongs to this region 1. We'll have more explicit and more formal definition of that later, but as long as you get the idea, that's good. Alright, so that's our first branch that corresponds to dividing into this region and to other regions, and the next branch will check on the hits. So if hits are, so it's around 100 here, less than 100, so now this branch of the tree, so this branch corresponds to region 1, and this leaf of the tree will correspond to region 2, region 3. So hits less than 10 is this region, so it's going to be region 3 here, right? So again, then your prediction y hat is just the average across all of the observations here in this region 3, all of the y values here. And if hits are greater than 10, then you will end up in region 2, and your prediction is going to be the average across all of the y observations that fell into, which have their axis falling into the region 2. That's pretty much it. So that's the definition of the tree model. The only question now we have is how to build those trees. So far what we did, we just visually looked at the graph and we try to visually split things into region. It works. We have 1 or 2 dimensional input. When you have high dimensional inputs, the visualizations won't work anymore. So we have to come up with a more formal algorithm of how to do those things.